Hello, class. Welcome to the wonderful world of dual credit geology. Um, okay, don't worry about it. We were just having a little in-class conversation for a second. Let's see. It's time to replace my lamp, if y'all didn't see that. It's been saying this for years, and this lamp never goes out. Well, the thing went out, not the lamp. But let's see. What you have in front of you is a lab. Again, I'm going to pause it for just a second. Don't have to put that on YouTube. They're going to be like, why did he stop the video multiple times during this video? I don't know. You'll never know. So this lab is actually pretty nice. You can see that it's been photocopied multiple times, and so the quality has gone down a little bit, but it is still a pretty good lab. For those of y'all at home, I will also post a picture of this, I guess, or I'll just type it into an email to y'all. We do have questions that you can omit, so you can go through right now and actually scratch those questions out. Number 1 through 3, you can omit. Just the C portion of question 6. So you still have to do A and B, 6A and 6B, but 6C you can omit. 11 through 14 you can omit. And at the very end, there's a companion website with some 4 questions about that. You don't have to do any of that. I don't even know if the website's still active. I believe that it wasn't a couple years ago. So these questions you don't have to do, and I will not put answers up on Canvas for you to be able to answer them. So I will get my online students a copy of this today, and I will start to put in an answer key on Canvas where you can put the answers in. But some of this stuff you're actually going to have to do on paper. There's some measurement things and a little bit of math. You don't have to do the math on paper, but the measurements probably need to be done on an actual printed out sheet of paper to make sure that you have the right distances and everything. So I just want to go over with y'all a couple things that we're going to have to do. First off, this is a pretty all-inclusive lab. And so I would suggest that instead of just going directly to question number 1 or question number 4, because we skip over 1 through 3. Where is 1 through 3?
It's with the graph above. I don't think you have it on here.
Yeah.
Oh, did I get rid of that page in the scan? What happened?
I think you did.
I just scanned it, so it must have not scanned properly. Y'all have it, right?
Yeah, it's right after the first page that you skipped over.
How many pages does this say it has? 4 pages? There's way more than 4 pages in this. What is this? What is this? Hold on, let me try a different scheme. Open this up. 4 pages? 4 pages. There's a lot. No, there's a lot more than 4 pages, even if you only do it one-sided. What happened? This is vexing me. Is this the one that I scanned? Oh, hold on a second. Sorry, online people. Okay, sorry to give a false start. And if you're at home, you get the privilege of not having to sit through that. So congratulations to you. So as I was saying, this one's pretty complete, and you can see that 1 through 3 is indeed on this page, and it doesn't skip straight to 4. This is a pretty complete lab. All the information you need to answer this lab should be contained in the lab. You shouldn't need to use the book. You shouldn't need to look up anything online, really, unless there's a term that you don't quite understand. You could always email me too. But I would suggest making sure that you read through the words. There's not a whole lot, but you will get to a question and be like, what are they talking about? If you're asking yourself, what are they talking about? You probably need to go back and read the paragraphs that are just before that question. Some of these images are bad now. There's also a couple questions that refer to images that aren't actually copied into this packet. And so those are the ones that I've omitted. And if you have questions about what to omit, just let me know. But make sure you read through these short little paragraphs. They're not too bad. Oh, come on. Why don't I just download this thing? Open it up on my computer as a PDF instead of doing this stuff. Let's see. So on this one, has anybody ever used pictures with scale before? There's going to be a little bit of scale math to do, which isn't going to be too bad. But essentially, here's how it's going to work. You're going to take a ruler. I would actually suggest that a piece of paper might be a little bit better. And let me show you why on both of these. So they're going to ask you to do some measurements, whether it's on this map, which they do ask you to do measurements on this map later, or on one of the later maps further down, like this one right here. They're going to ask you to take some measurements, and they're going to ask you to take those actual paper measurements and turn them into real life distances in miles and kilometers, more than likely kilometers, because miles is not really what we use here. So for instance, they're going to ask you the distance from the center of this mid-ocean ridge to the outside edge of layer C. And you have all these layers. They're going to have you name them or letter them on the other two images. They're going to ask you to take this measurement. So for example, I put my ruler up here, and it's about 5.5 inches. You want to be as accurate as you can, but on the projector here, I see about 5.5 inches. On your piece of paper, it's going to be very different. It's blown up pretty large here on the projector. So whatever you happen to measure there, you're going to put your finger there or write it down. Take your ruler down to the bottom and get a real life distance on this. And so for me, 5.5 inches, it's hard to see on the scale, is going to be just over 35 kilometers, probably like 36, 37 kilometers. And so that's going to be the distance that I have from the center of the mid-ocean ridge to sea. And that's what you need to do. I would maybe suggest not even using a ruler, because rulers bring in extra numbers that don't really need to be done. What I do to make it simple is just take a blank sheet of paper and do like a mark. Do I have a pen with me? Yeah, so I would set this up and then make a mark on my sheet of paper. And then I bring this down and I line it up with the 0, and then I just see where my mark is. And that way I don't have to worry about like 5.5 inches or 5 6/8 or something like that. You just look at where your mark is at and try to measure that. So a blank piece of paper does make it a little bit more efficient and convenient. Don't get your marks mixed up, because if you use the same side, you might have different marks. So maybe use different colors or switch to different sides or something, or just make sure you have the right mark. But that's going to be the kind of thing they're going to ask you to do. And so the same thing would apply up here. They will ask you to measure the distances from, let's say, New York to, I don't know what African city this is, but the coast of Africa right here. It probably tells you in the question. I think it's on a different page, just so you know. But I would measure from point A to point B. Get my piece of paper here, make a little mark where point B is, and I would go down to the scale at the bottom of the map, start at 0, and go over. And I can't really see the numbers, but I'm probably looking somewhere close to 7,000 kilometers. Try to be as accurate as you can. Don't round to like the nearest 1,000 or the nearest 10. Put what you actually think it is as close as you can get to that point. Because we're going to do a lot of math in this, not a whole lot of math, but you're going to have some pretty big number math, and so you don't want to be off by a whole bunch. If you get close, I'm going to give you credit for it, but I want you to be as close as you possibly can to make sure that you're getting all the work right. So make sure you're looking at the figures. Not always are they referring to the figure that's on this page. So here they say use figure 4. Figure 4 is not just above this question. They have figure 3 above the question. So you actually have to go to the next page to look at figure 4 to answer the question on the previous page. So just make sure you're looking at the proper figure when they ask you about stuff. Let's see. They're going to ask you to label these 3. I'm looking for just the plate interaction. So you have oceanic, oceanic, oceanic continental, and continental. And so you should be able to kind of see these. I will, like, somewhere I have a better scan of this. This is a terrible scan, and I have something very close to the original, which should have a little bit better images in it, hopefully. And so I will try to get that to y'all. We have, remember this is the polarized flip of the magnetic poles. And so you have your current magnetic setup, and then on this one, white is actually going to be reversed. So this is normal polarity. The white intervals are reverse polarity. So they're going to ask you a couple questions about this. I think this is a pretty good lab. Like, it phrases everything really well. It's very specific in what they want. If you have questions, please let me know. I'll be able to look at it and really help you out to be able to understand it. You will have some conversions, and so they do give you a little bit of help on the conversions. You will have to convert kilometers to centimeters. And so real quick, just to show you how to do that real quick, let me bring that over here. I mean, let's be honest, you're doing this from home, and we have people doing it from home. So if you get online and use a converter to just be like, how many centimeters is this many kilometers? No one's going to die. It's going to be okay. Like, it's fine. But if you want to do a little bit of quick math, it's not too bad. You have what? Centimeters is 100. So you have 100 centimeters equals 1 meter. And then 1,000 kilometers is equal to 1 meter. And so to go from centimeters to kilometers, no, actually you would be going the other way. You're going to measure in kilometers and then go to centimeters, because we're looking for a rate in centimeters per year. You would divide by, no. If you go from a big thing to a small thing, your number should get bigger. So you're going to multiply by 100,000 to go from centimeters to kilometers. So if I have 5 kilometers, I multiply by 100,000 centimeters per 1 kilometer. And what I get is 500,000 centimeters. That all made sense, and I feel really confident in that. But since it's on the video, I'm just going to double check. 5 kilometers to centimeters. Oh, the bell rang. Yes, 500,000 centimeters. So obviously I didn't get the full thing in today. I will go ahead and stop this, and then I'll record another video in second period